Okay, our second finalist in the development category is from Mortensen Construction. Presenting will be Sarah Maloney, Senior Integrated Construction Manager for the Spring Valley Wind Project, located on 7,600 acres of land managed by the Bureau of Land Management near Ely, Nevada. The Spring Valley Wind Farm's 66 turbines will generate 152 megawatts of wind power. Sounds pretty good. Sarah?
It is good. Thank you. Good afternoon, I guess. I guess we're afternoon now. My name is Sarah Maloney. I'm with Mortenson Construction. I am a Senior Integrated Construction Manager, which means I lead the virtual design and construction team for the renewable energy group at Mortenson Construction. I'm a civil engineer by trade. I have over about 20 years of experience with Bentley products, so I've been around for a little while as far as microstation and the civil tools go. Just want to tell you a little bit about Mortenson Construction. Mortenson Construction is a fairly old firm, started in 1954. We're located in Minneapolis, Minnesota. We're approximately 2,200 people, and we have a pretty diverse group of people. We do sports stadiums, buildings, data centers, and our biggest part of Mortenson is actually our renewable energy group, although it's not as well known because sports stadiums produce a lot of media. But we were just recently ranked #1 in wind construction by ENR. We're very proud of that. We're 10th in power construction overall. That includes power plants, but only one of which is actually renewable focused of those 10. In 1995, we saw a great opportunity in the wind industry, and we decided to pursue our first wind farm. And since then, we have built 123 total wind farms in the United States and Canada. The map that you're seeing there shows the different locations that we've built and the megawatts. Right now, this last summer, we had 18 projects under construction in the wind industry, partially due to the expiring tax credit in the United States. We've installed, almost 8,000 wind turbines, so it's a big industry for us. The Spring Valley Wind Project was built for Pattern Energy, and it is a 152 megawatts wind farm, which consists of 66 Siemens 2.3 80-meter turbines. So they're fairly large turbines. I don't know if you've seen a turbine in person, but it usually makes people go like this, wow. And it's quite impressive to see. We have turbine erection, site access roads, some underground collection, substation, the O&M facility, and a permanent meteorological tower that was also part of the project. Like Adam, we like Google Earth as well. And this project is built in Nevada. As you know, Nevada is the largest entertainment capital in the world in Las Vegas. Everybody likes to go there. But this project is built to the far north. It's 4 hours 4 hours to the closest airport. So it's very remote. It's very difficult for deliveries and people to access the project. It was so remote that we had to install satellite internet just to get connectivity. So. Although we've built about 125 wind farms now, this project is particularly interesting in that it was built completely on the land owned by the Bureau of Land Management. The Bureau of Land Management is the largest land management company or government agency in the United States, so it owns quite a bit of land. We found that 20 million acres of their land actually has wind energy potential, and only 440 megawatts of the 46,000 plus megawatts in the United States resides on Bureau of Land Management. And the reason is that this land is incredibly protected. It's very environmentally sensitive, culturally sensitive, and biologically sensitive. So when we brought this on, this particular challenge was one of our greatest goals is that we had to overcome. When we start a project, usually we want to go in and make sure that the customer feels that we are successful. So we sit down with them and we want to understand what their success factors are. A lot of times if we go in and say, we think you should do this, that's not really what they want. So the things that were important were that this is the first project in Nevada, and we wanted to make sure that everybody understood that it was going to be a great project and it looked good and we handled it well in Nevada. We also wanted to make sure that we exceeded their expectations. Going in for the first project in the Bureau of Land Management for us, we wanted to ensure that we had future work with them because of the potential of the land. We also wanted to make sure that on this land we were protecting and preserving those resources that were on the land so that we didn't have a negative impact once we were there. We also wanted to make a positive impact on the community. Wind energy is just a developing energy in the United States. It's starting to be well received, and we want to ensure that that continues. And then we also wanted to make sure that we had quality and schedule compliance. At Mortensen Construction, we have a team of approximately 40 virtual design and construction professionals that work on various different projects, and on every one of our projects we employ virtual design and construction. And this is our mission statement of our team, and we want to make sure that we're using innovative technology like Bentley products to ensure that we are successful. We find that building virtually first definitely makes sure that we have certainty of construction and certainty of pre-construction as well. So first I'll talk about how we exceeded the expectations of the BLM. This wind farm sits on more than 7,600 acres. As you can imagine, that's quite an expanse of land. I know when you saw the Google Earth picture, it looks like it's pretty compact, but considering the size of those turbines, it's not as compact as it looks. This sheer size of this wind park made sure that we had to have good collaboration amongst our team members. When they're out on site, every day we have a daily plan of the meeting where all stakeholders come and sit in the room. In the actual field office, we have whiteboards or interactive smart boards that are on site with electronic plans that we discuss the project and everything that they need to know for that day, including areas of concern. So if we have a cultural or biological area that they cannot be in, we need to make sure that they absolutely do not go into that area on that day. Afterwards, the plan of the day meeting, we also do we distribute electronic plans via tablets to the team members. We also, like I said, had satellite internet, and we do a morning stretch and bend every day to make sure that the team members are ready to go for the day. As you can imagine, if they're driving in, they may be tired. We work at various hours of the day. Sometimes due to wind, we work in the nighttime, so we make sure that everybody does a little stretch and bend. And for some people new to the project, it seems very odd. But the project teams, it's really well received. It's very simple and quick, but it's definitely well received by the team. The main thing that we did to exceed the expectations of BLM is we decided that they had given us an original area of 2.9 acres to keep each turbine site within. And we felt that we could exceed those expectations by planning out our work better as we do. And so what we did is we modeled each stage of construction, and we did excavation, reinforcement, and the various things you're seeing up here on the screen. But we took every piece of equipment that was going to be on site during that stage and laid it down so that even the vehicles, the trucks, the cranes, all of the excavation equipment, where the dirt was going to be located, and we planned it out. And we actually brought in the superintendents and foremen as a part of this process because if we don't engage those people, they'll never use the plans that we create. So we want to make sure that they're engaged as well. And so what we did is we piled all these different stages on top of each other, and we created a model of the whole process. So if you look up here and you looked real close, you'd see that there's trucks and parts and things on top of each other because of the different stages. So the green circle there represents the 2.9 acres that the BLM had given us. And we ended up actually using the red area with the road that's along there for 1.8 acres. So we saved 77 acres over the entire project site, which is a 40% reduction in the land impact. And when we submitted this to BLM, they were extremely excited about how environmentally sensitive we were, and we wouldn't have been able to do this without the quality of modeling that Bentley helped us with. We also, because we had created this great model, we had used inroads to create a model of every stage of construction. That's how we got our foundation for the model. And so we decided that we would take that model and use it for machine control grading. Now, machine control grading is not new. I mean, it's something that you're hearing a lot about. But on a wind project, the way wind projects are normally built is you go out there and you say, I'm going to build a road from here to here, and I go like this, and I'm eyeballing in my road. And we couldn't do that on this project, so we had to be more precise, and we wanted to make sure we were staying in those boundaries that they were giving us. We also excavated round foundation holes instead of square ones. Normally on our projects we have octagonal shaped foundations, and I'll show you them a little bit later, but we decided to excavate in a round fashion, which is a challenge to dozer drivers, but with machine control grading it made it much easier, and we were able to save 25% of the dirt from being moved out of the hole, so it was another great savings. Also, as I mentioned, the BLM, because it's very environmentally sensitive, we had to put all of our team members through environmental training so that they understood the issues that they were going to be dealing with when they were out there. So they would cover things such as how to handle topsoil. We had to make sure that we weren't disturbing it at all during the process. Dust control, weed management. We actually put in a weed wash station, so all trucks that were entering the project site had to be washed to make sure there were no noxious weeds on the trucks when they were entering the site. You can see the truck wash station on the lower left there, and we found that actually there was some local cows that liked the water that it provided, so they would hang out by our weed wash station and check things out. Another big concern is biological constraints. We had a cute little pygmy rabbits that decided they were going to nest right in the middle of one of our roads, and those pygmy rabbits are cute, but they're expensive. And we actually had to relocate 2 of our turbines because of the nesting pattern and their habitat that they had on our site. And if you look at our overall map of the project, there's a big horseshoe-shaped part of our road that should have been straight across because of those rabbits. We also had sage grouse and migratory birds, which caused a 200-foot work area where we could not work, which made us relocate cranes. We'd actually stop work, move to another part of our project, and I don't know if you've ever moved one of the large erection cranes, but that's not a small task. So we were continuously challenged by these biological constraints, and it really made it important for us to stay on schedule because we set our schedule based on their patterns of nesting. So if we got off schedule, we might get into that. We also set up a stealth camera to watch their nests. On the bottom, those are actually some live pictures from the project of the cute little baby birds, and it was kind of fun to watch those birds and their nesting. We also wanted to make sure that we had made a positive impact on the community, so we employ local residences as much as possible. We had 60 Nevada residents employed by Mortensen. It was almost 30% of the employees on site, which we were really happy about. We also had $1.6 million of revenue to 17 local businesses and $7.9 million of revenue to over 25 Nevada businesses. We also figured that because our construction travelers that actually work for Mortensen full-time live in that area, they contributed $1.2 million to the local area of their living and entertainment expenses, just on the side. We also encourage our team members to get out and impact the community on their own. And these are some things that they did. They had a golf tournament that raised $2,500 for the local BMX track, which was something that the community wanted to pursue. They installed some holiday lights, some high school tours. So what they do is they bring the kids on site, give them the full safety program, show them the turbines. They don't let them climb them. They're a little bit out of our safety issues, but it's a lot of fun. And then we also have a program that's called Catch the Wind. It's an elementary school book that one of our team members wrote about how to erect a wind farm. And we go into the school and we teach them all about the wind farm. And what's fun about that is these kids see the wind project being erected and they understand what's happening out there. And so it's a very fun program for them. We dress them all up in our safety gear and bring all kinds of props, so they have a great time. Some other things that we did, it takes a tremendous amount of rebar to support these 80-meter tall turbines. 69,200 pounds of rebar in our largest foundation on this project. We had 2 different foundations. So what we did is we wanted to ensure that quality was reached the first time. And so we decided that we would model our foundation rebar using Bentley rebar and some other microstation tools. And we take the electrical conduit that feeds its way through it to ensure that there are no clashes with that electrical conduit. That electrical conduit is normally an in-field modification because usually our rebar designers have it all done before we get that electrical conduit design. So we wanted to make sure that we did not get that. And then there's just a couple pictures there to show the process of the rebar. Another thing that I wanted to point out is that this is our schedule for the foundations and the erection. And the smaller, narrower bars, they're kind of in yellow, it's a little hard to see, is our actual planned schedule. And the black bars are what we actually completed. So you can see that all of those things were finished ahead of schedule. We're very proud of that. It was a very challenging project. There was a lot of rain, a lot of wind days, a lot of bunnies to deal with. And I'm happy to announce when I originally submitted the project was still under construction. And now we've completed it. We've energized the project in August. And these are just a few pictures of the very proud team erecting the last turbine. And the man on the upper right is standing on top of the turbine. And I don't know if it's on your bucket list, but it should be. It's quite a rush to stand on top of that turbine, seeing that. And you can even see on the lower right, he's standing there waving to the guy on the turbine next to him. So we had a good time erecting the turbine. And we even finished our very own first substation that Mortensen self-performed on this project. We received a couple quotes from our partners that we're really proud of. I think that we really set the tone for BLM projects for us. We exceeded their expectations, and I hope that we will be doing more BLM projects in the future. It was quite fun. And Bentley really made an impact on this project. It optimized our parts laydowns, it supported machine control grading without any problems. We were able to export shape files when we had those changes in the roads so that BLM, who doesn't use CAD software at all, they said they're completely GIS. And so before we had a third-party project, so we just used Bentley Mapped to export those shape files for BLM. It also enabled those agile road changes because of the roadway designer. We had the model already complete, and like Adam mentioned in his project, it's very simple to change your roadway and quickly rerun the model. It also eliminated rebar conflicts. On the upper right, you can see where we used clash detection to find those rebar conflicts, and we were able to resolve them before they occurred. And in that particular case, I think every piece of conduit clashed with the rebar, so we were lucky to have that resolved. And then also we reduced that overall project footprint. That is a huge savings. 77 acres on that much land we're really excited about it, and I think it made a great impression. And so at this time, I'll take any questions.
Questions?
Great presentation. Does your firm also do the site investigation to determine if that's a good location? And if you do, are you using any of the wind LiDAR technology?
Typically, we receive that information from our project owners, but we do go out with them and do some siting as far as, like our other projects that are on more mountainous terrain, we give them a lot more impact, as far as where turbine parts will fit, that kind of thing. We don't actually do the original siting, however.
Great presentation. Question, are you applying this technology? Where is the next step besides, let's say, wind tunnels? This site planning, what other area of construction are you applying this?
We actually have found that since we did this project, we did the modeling probably almost a year ago now originally, and we've found that on all of our other projects that it has a great benefit to our other projects. Since we've done it, it kind of becomes the norm for us. We haven't, we do parts laydowns because a lot of times if we're laying down parts in a mountainous area, those parts will hit the side of a hill. And so we want to make sure that we go in knowing exactly what we're going to encounter, make sure that our turbine sites are large enough to encounter those things. As far as Mortensen goes, virtual design extraction is our standard. We model everything, and we have integrated extraction team members that are on site with our construction personnel that are working with them full time to make sure that we have everything known before we're out in the field building it.
One more question. Is there a photo of you on top of the turbine?
I know, I'm too scared to get up there.
Thanks, Sarah. Anthony Oliver, new civil engineer. Two questions. I suppose, firstly, you don't mention how much the project costs, but I think it's confidential. But can you say how much do you think the savings that you made in the design have impacted the return on investment? What is the return on investment period for this project? And secondly, are you able to use, or is the owner able to use the modelling you've done in presumably what is a fairly comprehensive and ongoing maintenance program that it has to have from now on into the future?
As far as what we've saved, I think that the savings is probably not in dollars necessarily. I mean, obviously the BLM owns the land, and because we're not actually buying more land because of the savings, it's not really in the savings that in dollars I would put it. I would say we put it in, the savings was more in what we didn't impact culturally, what we didn't impact biologically. If you asked BLM, I'm sure they would confirm the same thing, that we did not make that impact on the land is the great savings that we had. I don't think there's a dollar value you can assign to that type of savings. And as far as turnover, we turn over the model to the BLM. They would be getting some sort of GIS type shapefile. I don't honestly foresee them using the model as it stands, but I do see that they will use the information to their benefit.
Why wouldn't they use the model?
I think that they're, because of their level of CAD at BLM, they probably would not have the capabilities to use it.
Any other questions?
Great project. Do you see this pulling you into 4D and 5D as next steps?
Actually, we do use 4D modeling on our projects to relay our project schedule to our owners. We did not do a 4D model on this particular project, but we do it on some of our more mountainous projects. We have some projects in British Columbia that are extreme terrain, and we do that as well. And then as far as 5D, we are also doing some 5D modeling with adding costs to our model to make sure that we can interactively make revisions and see the outcome automatically.
Who does the design, the layout, the spacing of the configuration of this whole thing?
Usually the Pattern Energy would have done that original layout. It's based on the size of the turbine, and so the turbine manufacturer would have a standard distance that they recommend between their turbines, and then that is given to us along with the engineering.
Hi, Marty Scroggins, Technical Director for American Engineering. There's lots of technical aspects I could bring up and talk about wind farm design and construction, but I won't. I just wondered if you could show us your bend and stretch regime. No?
All right, everybody stand up. The bend and stretch is really great. It's very simple. It's very simple stretching. We aren't doing jumping jacks or push-ups or sit-ups or anything like that. It's just to loosen up your joints and make sure that those repetitive motion injuries don't occur.
How many people does it usually take to support your virtual pre-construction efforts on something like this?
Our team itself consists of 3 people in the renewable energy group. We support all 18 of those projects, so as you can imagine, we are quite busy. But we also have our field engineers that are young engineers on site that we bring in. They usually have a level of expertise as well that help us out. They're usually the ones that are running the smart boards and the daily electronic plans. Also, the project engineers are all trained in all of the, this type of work as well. So we have a quite high level of expertise technologically. Thank you very much.